So here, ensure that the system will never enter a deadlock state. How is it we handle the deadlocks? First of all, we'll try to see to that we'll maintain the system such that the system should never enter a deadlock state. Second one, you try to do the first step. If not possible, allow the system to enter a deadlock state, then recover. So if you could not control, if you could not avoid, if it is already, your system has entered a deadlock, then what is the next option I have? Try to recover it. So that is how we are going to handle the deadlocks. Third one, if at all, if you are unable to recover, so what is it I can do then? Ignore the problem, the deadlock problem, whatever is arrived, no, you ignore that and pretend that deadlocks never occur in the system. So you try to see that deadlocks will not appear at all. So these are the things which are used by most of the operating system, including Unix. So what are the methods in which I will handle the deadlock? Firstly, I'll try to maintain the system such that it will not and never it will enter a deadlock state. So I'll try to do this. If not possible, if the system has entered a deadlock state, then I'll try to recover it. If I am unable to recover it, then I will assume that I'll ignore the deadlock problem appeared. Then I'll continue with the rest of the process. So moving on to the topic deadlock prevention. This is one of the technique of handling deadlocks, right? So coming to this, so here we have listed the ways requests can be made. These are the techniques comes under deadlock prevention. First technique is mutual exclusion. Then I have hold and wait. So here in the mutual exclusion, what do you mean by mutual exclusion? If any one process is executing, if for example, if I have some section called critical section, right, where you have set of code to execute the given process, right? So if at all, if I have one of the process in the critical section, I will not allow any other process to the same critical section at the same time. So I mean, mutual exclusion means what? Not required for shareable resource, must hold for non-shareable resource. That's what. Once I have allowed one process to execute, I will not share this resource to any other process. So I will go for a non-shareable resource. I will hold the process such that it will not share the resource. That is the technique under mutual exclusion. So what is the next step? I have hold and wait. Must guarantee that whenever a process requests a resource, it does not hold any other resource. Say for example, now I have process say P1. P1 is requesting for some resource say R1. It does not hold any at that time. You should not hold any other resource say R2 because it is requesting for R1, right? When say same time you assume that this R1 is assigned to some other process say P2. So P2 has to release R1. Then only I can do P1, right? So if R1 is not ready, why it has to hold for R2 then? At least if it will release R2, some other process will complete the job, then it will relieve both the resource. I mean R1, R2 both can be released by the next process. So when there is no, you must guarantee that whenever a process is requesting for some resource, at that time, that means what? Whichever the resource it is requesting for, that is currently not available with the process, right? When the requesting resource is not currently available, then whatever the resource is already holding, better it has to release it to some other process. That time it should not. You should maintain the system such that if any process is requesting for any resource, at that time same process is holding some other resource. So you have to try to make that process to release that resource, so that any other process requesting for this particular resource can complete the job. That is how you will try to prevent the deadlock. Fine. So these are the two steps carried out here. Require process to request and be allocated all its resources before it begins execution. Right? See for example, it has R1 but it is waiting for R2. What is the use? So instead of facing this circumstance, release R2, wait for the other process to complete the job, then get both R1 and R2, then you can go back to your job, right? So or allow process to request resources only when the process has none. That means what I am trying to do, if I want to complete P1, right, then it is requesting for some resource, that time it should not hold any other resource. I mean, it should, if it is requesting for R1, then P1 should not hold R2, R3, R4, so on. So if there is no resource with P1, then I will think whether I can allocate the resource or not. So if this is the case, what is there in the next step? No resource utilization. If I continue with this, that means what? Whatever the utilization of resource I am doing, I mean, I am taking care that If R1 is not available with P1, then I am not allowing P1 to hold R2, R3, R4, so on. And that means what? I am unable to utilize resource R2, R3, R4, so on. So that means what? You are going for low resource utilization. If this is the case, there may be a chances of starvation, because I don't know whether I will complete, what time I will complete the other process, what time I will come back. I mean, P1 may be in the indefinite blocking. I don't know when I can complete P1. Because even though P1 has some resource say R2, since it is requesting for R1, so I am not allowing P1 to hold R2. So I am forcibly taking R2 from P1. So when I am doing this, P1 is going to be in loop. So there is a chances of starvation. But I am now the third technique as no preemption. The fourth technique is to handle the circular wait. So coming to the third one here. What is no preemption? Preemption means what? Trying to postpone. No preemption means what? You are not trying to postpone. You are not preempting at all. So how is that? If a process that is holding some resource requests another resource, that cannot be immediately allocated to it. Correct? No. P1 is holding R1, but it is requesting for R2 or R3. Immediately how it is possible to allocate? Because that time maybe R2 is held by some other process. So then all resources currently being held are released. So whatever R1 it has to release, right? So preempted resources are added to the list of resources for which the process is waiting. So I mean, indirectly, the technique is no preemption. How is it I am doing? These are the steps, right? So here, what is it you are doing? P1 was requesting for R1 and it was holding R2, you assume. But since R1 was not assigned to P1, I will take R2 from P1, right? So indirectly P1 I am preempting, right? So this preempted resource, I mean, whatever R2 you have, that you are going to put it in the list of resource, so that other process which are waiting, I will not preempt such process, that I will continue with the available resource R2, fine? So process will be restarted only. I can come back and restart the P1 only when it can regain its old resource. I should get back. See, for example, P1 is requesting for R1. At that time it has R2, but it has already released R2. Now, once R1 is assigned, it has to get back its old resource, which was that R2 also. So if both old resource and new resource both are available, then only I can continue my P1. So this is how preemption and no preemption is done. Fine. Coming to the last one, circular wait. Impose a total ordering of all resource types and require that each process requires resources in an increasing order of enumeration. So circular wait means what? P1 is waiting for P2, then P2 is waiting for P3, P3 is waiting for P4, so on. So if this is the case, so if P1, I cannot complete P1 because of P2. I cannot complete P2 because of P3. So what is the solution then? So I have to complete in the reverse order, right? So first, how is it you will do? What are the number of resources you require to complete this? What is the order in which you will assign the resource to each of these processes? That is very important, and require that each process requires resources in an increasing order. So increasing order, why? P1, then P2, P3, P4, so on. So you have to check that how many resources are available and what is the order you are going to execute the process, and how best you will assign these resources to overcome this circular wait. So if you overcome this, definitely you are going to prevent the deadlock.